The next topic is on complex algebraic fractions. Complex algebraic fractions contain algebraic fractions in the numerator or denominator or both. A complex algebraic fraction must be reduced to an ordinary algebraic fraction. An ordinary fraction does not have fractions in its numerator nor in its denominator. A complex fraction is reduced to an ordinary one by using a combination of the operations add, subtract, multiply, and divide. We have x plus 1/2 over 4. Now this means that x plus 1/2 is divided by 4. The numerator has a fraction, and the two terms must be combined by adding them. So now we have x plus 1/2, x plus 1/2 is equal to, common denominator is 2, resulting in the fraction 2x plus 1. The original problem then amounts to 2x plus 1 over 2 divided by 4. We can now continue with this problem by using the rule for division by a fraction, change this into a fraction using 4 over 1, and taking its reciprocal and continuing by multiplication. 2x plus 1 over 2 is then multiplied by 1 over 4, which amounts to 2x plus 1 over 8. Another example, have x over 3 plus x over 5 all over 1/2. By the division method, we observe that this is equal to x over 3 plus x over 5 divided by 1/2. See how this translated into this expression. We must combine x over 3 plus x over 5, first using the common denominator 15. 3 into 15 is 5, 5 times x is 5x. 5 into 15 is 3, 3 times x is 3x, and we have 5x plus 3x. Now, change this to a multiplication sign and write 2 over 1. Of course, we better add 5x and 3x since that can be simplified. We have like terms there, so 8x over 15 is multiplied by 2, or 2 over 1. Result is 16x over 15, an ordinary algebraic fraction. In another example, we have 1 over 2x plus 3 over y over 1 over x and minus 2 over 3y. This means that the numerator, 1 over 2x plus 3 over y, is divided by 1 over x minus 2 over 3y. Now each of these, both the numerator and denominator, involves an expression where we're either adding or subtracting. In adding or subtracting fractions, you must have common denominators in order to simplify the expression and write it in its best form. We'll begin with the first one and work out the result separately. The common denominator for 2x and y will of course be equal to 2xy. Take 2x, divide it into 2xy. Y is the result. Y times 1 is y. Y divided into 2xy is 2x. 2x times plus 3 is plus 6x. Divided by, we have a common denominator 3xy. X into 3xy is 3y times 1 is 3y, followed by 3y into 3xy is x. X times that is 2x. We have two fractions to divide now, and applying the reciprocal rule, we have y plus 6x over 2xy times 3xy over 3y minus 2x. It appears that the numerator here can't be factored further, neither can the denominator here be factored further. We have xy, a factor of the entire numerator, and xy below here, a factor of the entire denominator. This is, of course, treated as a unit. So we can drop the x and we can drop the y, and we cannot reduce the result any further. The final answer is 3y plus 6x, but I will write that in alphabetical order. And in the denominator, we have 2 multiplied by 3y minus 2x. If you want this in alphabetical order, you'll have to put a minus sign in front here to compensate for the change or switch in the terms. And so the final answer can be expressed as negative 6x plus y over 2 times 2x minus 3y. There doesn't seem to be much improvement in any one of those extra fractions I wrote, so any one of them would have been satisfactory. In another example, I have 1 over x minus y minus 1 over x plus y, all upon 1 over x minus y followed by 1 over x plus y with a plus sign in between. The interpretation of this complex algebraic fraction is that we will want to take 1 over x minus y, 1 over x plus y, and divide this by 1 over x minus y plus 1 over x plus y. Now these are fractions which must be added or subtracted before continuing. Taking each fraction separately, take the denominator of the first fraction into the lowest common denominator. The answer is x plus y. X plus y is multiplied by 1 times 1. X plus y into this amount is x minus y, and that's multiplied by negative 1. So negative 1 times x minus y goes in that place. Divided by, we haven't got a single fraction on the right yet, so we cannot change the division symbol into a multiplication one. We'll do that when we're done with adding these two fractions. Common denominator, we have 1 times x plus y, followed by plus 1 times, divide that out, x minus y. Simplify these as much as possible. We have, I'm going to do this work on top here. It seems that we're going to end up with a lot of lines, and it's just a matter of doing small little changes. So I have 1 times x plus y, that's x plus y. This is going to be minus x plus y here. Negative 1 times that, negative 1 times that. Over here I have x plus y plus that, which is plus x minus y. You end up with 2y on top, followed by x minus y and x plus y below. Divided by that and that amounts to 2x, and the y's subtract to give 0. X minus y, x plus y. So now we have two fractions which are divided. Apply the reciprocal law. 2y over x minus y times x plus y, followed by a times sign, and x minus y, x plus y over 2x. These are all multiplied across the top and multiplied across the bottom. These are all factors of the entire numerator and of the entire denominator. We can therefore find matching common factors in the numerator and denominator and cancel them out of the problem. So we have x minus y there that'll go with that, x plus y that'll go with that, and the 2 which will go with that. And look, what we have left is simply y over x. The next way to deal with complex fractions, to reduce them to ordinary ones, is to use the LCD method. I will do the same examples over again as I did earlier with this method in mind. This is actually the preferred method, and we would like you to learn this one over the other. Let's begin with the first example I gave before. X plus 1/2 all over 4. The procedure here is to identify each term of the problem. As in this example, x is a term, 1/2 is the other term up there, and you can consider 4 as being a single term as well. Where you do not have a fraction specifically for a given term, change it into a fraction by putting 1 underneath it. In other words, x over 1 looks more like a fraction now, and 4 over 1 looks like a fraction as well. We're going to use the so-called principle of equivalent fractions, which means if you multiply any fraction by something that's equivalent to 1, like 2 over 2, 4 over 4, 10 over 10, and so on, and change the appearance of the fraction, of course, the result will be something that looks different from what you started with, but it will not be any different in value. It'll be the same value, even though, as I said, the appearance will be different. The LCD method here requires that you look at every denominator of every term. Now here's a denominator 1, here's a denominator 2, and here's a denominator 1. So the denominators of each term in the complex fraction are 1, 1, and 2. Of those denominators, determine what the lowest common denominator is. Now the lowest common denominator here in this simple example is just 2. So now make a fraction equivalent to 1 using the lowest common denominator. The lowest common denominator is 2, and so the fraction that we want equivalent to 1 using that number is 2 over 2. There's 1. And there's the LCD. Use that fraction and multiply the complex fraction, and it'll automatically, through the process, become an ordinary fraction. 2 multiplied by x is 2x. 2 multiplied by 1/2 is 1. 2 times 4 is 8. And that's the answer. Let's do the next one, which is x over 3 followed by x over 5 all upon 1/2. look at each part of the complex fraction. The terms are x over 3, x over 5, and here is a single term, 1/2. What are the denominators of each of those terms? The denominators are 3, 5, and 2. What is the LCD of 3, 5, and 2? So the LCD here is 30. Use the lowest common denominator in a fraction equal to 1 and multiply it with the complex number. In other words, what we're saying is take 30 over 30 and multiply here across the top and down here across the bottom. If you take 30 and multiply it by this amount, 30 is multiplied by x over 3, and that 3 times 30 is simply 10x. X over 5 times 30, that's 6x. 1/2 of 30 is 15. 3 is 10x. 10x plus 6x is 16x over 15. 1 over 2x plus 3 over y. All over 1 over x minus 2 over 3y. Now, each of these terms do have denominators, so we don't have to enter any ones to make up for those that are missing. We have as the denominators of each term as 2x, y, x, and 3y. Those are the denominators. We'll go right to the LCD and not list the denominators separately. We can see what they are. In the LCD builder, the first factors are members of it. Y is not represented. Include y. X, well, x is already represented, so we don't need that. Only the 3 is not represented, so we include 3. So 6xy is the lowest common denominator. So you multiply this by 6xy over 6xy. Now taking 6xy, multiply it by this term, followed by multiplied by this term. And in the numerator, we will get, you can do part of this in your head now, 1 over 2x times 6x amounts to 3y. So 3y goes there. 3 over y times 6x, y's will be gone, leaving 18x plus 18x. On the bottom, we have 1 over x times 6xy. That'll be 6y. And finally, 2 over 3y times 6xy is equal to 2x times this is minus 2x. Continuing, we have 3 times y plus 6x over 2 times 3y minus x. And finally, in one more example that I did earlier, using the division method, we have 1 over x minus y, followed by minus 1 over x plus y over 1 over x minus y and plus 1 over x plus y. The LCD will be easily determined as equaling x minus y times x plus y, and so make up a fraction where these are used and where the fraction equals 1. Take each of these parts of the fraction and multiply it by that one first and followed by multiplying it by that one next. one at a time. 1 over this amount multiplied by that results in x plus y times 1, and we'll leave it at that. And then when you take minus this amount multiplied by that, you'll have x minus y left over times minus 1. So minus 1 times that is minus x and plus y. In the bottom, we have 1 over x minus y times that amount, and we'll end up with x plus y times 1, x plus y. Multiplying here by the denominator, we're left with plus 1 times x minus y. Simplifying, now we have x minus x is 0, we have 2y, y minus y is 0, we have 2x, and that's y over x.